3, 2, 1. Now you are live.
Good afternoon, everyone. I'm Shuli Mitra from the Office of the Principal Scientific Advisor to the Government of India. On behalf of the Office of PSA, our organizing partner FICCI and Pune Knowledge Cluster, I welcome you to the fourth session of the Innovation and Science at Bharat series. The three organizations have come together for a series of knowledge sharing sessions to bring together experts who will share their experiences of building and nurturing industry academia engagements. The series is meant to reach out to young entrepreneurs, researchers, and research managers working at the interface of industry and academia from across the country. You can also watch this session live on our YouTube channel. The attendees can type in their questions in the YouTube chat box, and we have our team looking at them. Inform everyone that the PSA will not be able to attend today's session as previously planned. So we will move on to the rest of the session. I welcome Mr. Dilip Chinoy, Secretary General FICCI. Mr. Chinoy leads the permanent secretariat of FICCI. It's the largest and oldest apex business organization in India and a potent voice for policy change. Before joining FICCI, Dilip served as Managing Director and CEO of the National Skill Development Corporation, NSDC. He also worked with several key industry organizations, including SIAM as the Director General. With varied experiences of working in the private sector, he advises startups, including organizations in the digital education, skills, and livelihood space. A fellow of the World Academy of Productivity Science, he was awarded the Indian Achievers Award in 2018, the Game Changer Award in 2015, and the Rashtriya Media Ratna Award in 2013. I now invite Mr. Dilip Chinoy to share his thoughts on how industry in India and academia can partner to help achieve India's economic and social development goals.
Thank you, Shirley, for that very generous introduction. A very good afternoon to all the panel members and everybody who is actually participating. First of all, I hope all you yourselves, your family members, your colleagues in the workplace are all keeping safe and keeping happy. One very special request, I know that most of us are on this screen are in our own rooms individually and in isolation, but please do wear masks all time and maintain social distancing, and also please follow wash your hands and other sanitization protocols. A very good afternoon to all of you. I would like to thank, I know he's not with us, but I'd like to thank Professor K. Vijayaraghavan, Principal Scientific Advisor to the Government of India and his office for actually allowing FICCI to partner for this very important program under the Science and Innovation at Bharat initiative. As Soali mentioned when she introduced the topic, it's really to bring people who are in the academia together with young entrepreneurs and actually even business, because it is our firm belief that one, academia does not know what business is doing, and business has no idea what research people in academia are doing. Not only the challenges, even if they have an idea, the ability to spot an opportunity and to commercialize it and to look at an opportunity to actually improve the scientific temper and scientific collaboration within the country is actually leaves a lot of opportunity to take it further. I think here in this series, we are actually focusing on the significance of industry-academia collaborations to address the societal challenges using emerging technologies. I think this cannot be emphasized more. And this initiative of knowledge sharing on the use of frontier technologies to address these societal challenges will definitely help young researchers, entrepreneurs, academicians, and industry to come forward and adopt best practices for fostering such collaboration. I think that for this quarter, this focuses on the theme of artificial intelligence and its applications in the area of healthcare, agriculture, education. It is heartening to see the focus and concerted efforts from government and stakeholders to ensure that inclusive growth and we can charter a course for the use of AI for social empowerment and transformation in the key areas like healthcare. Today, I believe we are really going to focus on healthcare. Given the current wave of the pandemic, it could not have been more apt. If I were to take 4 areas where currently we are facing a challenge, it's nothing new. All of us are reading it in the papers or listening to the news or getting WhatsApp messages on the different groups that we are. One, there is an information asymmetry across 4 different requirements in the present. One is the availability of hospital beds. Secondly is the availability of oxygen. Third is the availability of medicines there. And the fourth is the whole availability of slots for vaccination. In fact, the CoWIN app is a great example of how you can actually use artificial intelligence and digital technology to solve a vaccination problem. But then in a real-time basis, actually enabling it for the public to know and the public to be given enough time to actually see where to go for vaccination is something which both academia and industry could work together. Today, we know in all the hospital beds that have been requisitioned by the government, there is some clarity, but actually there are 2x or 3x hospital beds which have not been requisitioned by the government for COVID. And there is no way to actually get that onto ecosystem or use artificial intelligence or whatever it is. For example, artificial intelligence is really machine learning, right? So we have in the healthcare space TPS, third-party people who actually approve cashless payments. Now, if you link them and the hospital and a system, so when a person starts processing his payment, you actually will, someone can say that bed will be available after X hours or something. So there is a lot of things to actually use the machine learning capabilities to address the bed availability problem. And what we have been hearing over the past few days on the oxygen issue is that there's a mismatch where the oxygen is being produced, where it is being consumed, where the tankers are, where the cylinders are, and the whole transportation thing. And this is a classical thing for an entrepreneur to put 3 or 4 best minds together, including researchers from ISI Kolkata, because after all, it is a statistical issue and it's a mathematical algorithm that needs to actually come in here. So there's a great opportunity in this area, and I think everybody needs to come back and work together to solve these problems. There is not only an opportunity, immediate opportunity, let's say in the COVID situation, right? There is an opportunity worldwide. If you look at UNCTAD's Technology and Innovation 2021 report, right? It shows that frontier technologies currently represent a $130 billion market, and it's going to grow to 3.2 trillion by 2025. And unless academia and industry and entrepreneurs and organizations work together, right, the artificial intelligence market, which is going to reach, 191 billion by 2024, we need to have a significant share of that market when we look ahead. Of course, the Indian ecosystem is good. A lot is happening. In fact, in the healthcare space also, a lot is happening. You also have the vision of becoming a $5 trillion economy. And I think unless science and innovation and industry and academia all work together and we build on it, while we made it to the top 50 in the Global Innovation Index for the first time, sustaining this and going into the first 25 of the top 10 will be an ambition worthy of aspiring to, but it requires all of us working together. Of course, the Niti Aayog and the government actually talked about a national strategy for artificial intelligence, AI for all. It identified where it could be used, including healthcare, agriculture, education, urban, smart city, infrastructure, transportation, mobility. These are all areas where we can actually work together, and it can boost India's annual growth rate by about 1.3% by 2035. The ARAWAT, which is the AI Research, Analytics, and Knowledge Assimilation Platform, which lays down India's approach to the development of AI-specific cloud computing infrastructure, was released in January 2020. The development of ARAWAT will democratize the access to critical hardware that is important to drive AI research and development. There are many opportunities and challenges, and it could bring, introduction of artificial intelligence could also enhance the education sector. Many schools and higher education institutions in the country face a wide range of challenges. The pandemic has actually accentuated some of them. There are a lot of ways to actually engage students, reduce dropout rates, and the typical thing of teaching over the top or one size fits all can be adaptive through using adaptive learning and artificial intelligence and big data. In the health sector also, there are pilots. The Pradhan Mantri Jan Arogya Yojana (PMJ), which really aspires to provide cashless health insurance cover to all. It will provide AI will be proved to helpful in empowering better service delivery, promote inclusivity of population groups, detect fraud, and increase accountability. Of course, the National Digital Health Mission is another new initiative where this could be used. And if everybody actually collaborates, academia, the healthcare providers, the diagnostic labs, the doctors, everybody in the ecosystem, it can really be a game changer for India. Similarly, diabetic retinopathy is another thing which Niti Aayog and the PGI MER are driving a pilot onto integrating an AI platform for screening diabetic retinopathy in public health facilities. Another third example, there are many, many more, and I'll just take a third example, which is Cancer Biobank, and Niti Aayog in collaboration with the Tata Memorial Center, Tata Memorial Hospital, IIT Mumbai, AIIMS New Delhi, PGMI Chandigarh, the Rajiv Gandhi Cancer Institute and Research Center is driving the cancer imaging biobank for head, neck, and lung cancers. I think this project is being funded by the Department of Biotechnology. There are many initiatives. FICCI also has taken a number of initiatives here. We have actually got a group of over 11,000 startups whom we are connecting with industry. We have the AICT FICCI Atal Faculty Development Program on Artificial Intelligence. This 5-day, it's a faculty development program to upskill 200 faculty members from across India was actually held in June 2020. The FICCI AI India Conclave to advance the cause and impact dialogue around artificial intelligence and machine learning in India. It really focused on leveraging AI for digital transformation, ethics, and security around AI, transforming healthcare, which is our subject today, using AI and robotics. I believe that the opportunities are immense, and today's session seeks to bridge a very, very interesting divide that the academia doesn't know what industry is doing, industry doesn't know what academia is doing, and even if they don't know how to leverage it going forward. I believe there is a huge opportunity to collaborate and go forward. I believe that if we were to look at very, very simple things of collaborating, of doing this here, and one suggestion, Soali, for your consideration, if we can task in the next series that we have, if we can task 2 sets of people to write kind of a background paper. The first paper could be an academic background paper saying, for example, what are the different AI healthcare linked initiatives happening in the various educational institutions and research laboratories in India. And the second one, I think Pankaj and Sumit and Manav and our friends from Intel, if we can actually then similar develop a paper what industry is actually doing, and that would and even get 2 of them to make short 5 to 7 minute presentations, and that will surely help in enabling both sides to know what is actually happening and also identify great areas of synergy. Again, once again, I want to reiterate our great gratitude and thanks to the PSA's office for enabling FICCI to partner. Thank you, the Pune Knowledge Cluster and Professor Ajit Kembhavi for your help and support. And I wish, that all of us come out of this session with a greater understanding of what is happening in India and at least one idea for partnership. Thank you. Keep safe and keep well.
Thank you, Mr. Chinoy. It was, I have to thank you for shedding light on today's session and the ones that come and the upcoming ones. Your suggestions about listing out those institutes who are working on AI are well taken. I'm sure I'll talk with your team at FICCI and work towards it. I'm sure that your pointers on challenges that uniquely ail India and the world will be useful for everyone here. Mr. Chinoy enumerated some successful engagements between academia and industry from across the country, and today we deep dive into a few. We are joined by experts from organizations who are working on the applications of artificial intelligence to revamp healthcare in India. From academia, we have with us Professor Sangamitra Bandyopadhyay. We know her for her work in algorithmic optimization and for its significant impact on biological data analysis. She joined the Machine Intelligence Unit of the Indian Statistical Institute, Kolkata, as a faculty member in 1999, and then went on to head the institute. She is also a member of Prime Minister's Science, Technology and Innovation Advisory Council. Today, she will share with us the lessons she learned while building and then nurturing industry partnerships as the director of ISI. Over to you, ma'am.
I'll share my screen. Just hold on.
Please.
Just hold on, please.
Sure.
The share button should be somewhere at the bottom, right?
Yes, the
Yes.
share
Why is it
is at the bottom.
Why is it not coming? I'm surprised. Where is it gone? It was there a while back.
Maybe you can try after stopping your video, ma'am. Just stop your video
Okay.
and then try. Probably it will happen.
Just hold on. No, but all those, yeah, now I get it back. Yeah. Okay. PPT. Yeah, can you see my?
Yes, we can see your screen.
Yeah, just hold on. Is it now full screen?
It is.
Yeah. So first of all, I would like to thank the PSA's office and also Professor Kembavi for thinking about me when this initiative was launched and AI in healthcare. This is an area where I have been working for some time, and I must admit that this disconnect, which Mr. Chinoy just mentioned, this disconnect is indeed there in the academia industry disconnect, and it's not that. I mean, although we are trying, there's a lot to be done before this gap can be bridged. And I am also personally trying. I'm trying through my institute because, as has already been mentioned, I come from Indian Statistical Institute, and this being primarily a theoretical research in the Theoretical Sciences Institute, research in mathematics, computer science, statistics, but primarily on the theoretical aspects. So this disconnect is something I feel quite heavily. But we've been trying to rectify the situation, and the way the country is also moving, where with a large amount of focus on industry, academia collaboration, a large focus on building startups. So I think in the years to come, we will see a remarkable change. As has already been mentioned, I'm Sangamitra Bandyopadhyay, and just a slide about Indian Statistical Institute, established in 1931 by Moholy-Nebis. You can see his picture on the right-hand side. And we are spread all over the country with the headquarters in Kolkata and centers in Delhi, Bangalore, Chennai, and Tejpur in the Northeast, and a smaller presence in other cities Overall, we have presence in about 10 cities of the country. We have, besides statistics, mathematics, as you can see at the top, applied statistics, and it closes with theoretical statistics and mathematics. We also have biological sciences, very strong group of computer and communication sciences, physics and earth sciences, social sciences, statistical quality control and operations research. We are primarily a research organization where our PhD programs are the primary focus, but we have 2 bachelor's level programs in statistics, mathematics. We have 5 MS level programs, 3 MTech level programs, 1 in computer science, 1 in cryptology and security, and 1 in quality, reliability, and operations research. Besides this, we have postgraduate diploma programs. This 2-year postgraduate diploma program is something I think is the way to go. It is in collaboration with 3 different institutes of Eastern India, the Indian Statistical Institute, IIT Kharagpur, and IIM Calcutta. It is called Postgraduate Diploma in Business Analytics, PGDBA. First semester, the students spend in ISI, learning statistics and mathematical tools and techniques and methods. Then they move on to IIT Kharagpur for their second semester, third semester, where they get the technological aspects. They learn the management-related aspects in IIM Calcutta in the third semester, and the fourth semester they do their internships. This, I believe, is a unique model and a model to emulate for the entire country, where the expertise of the best institutions get passed on to the students. And not only academic institutions, I believe, if we can come up with best academic organizations and best industry together, teaching the students, that would be a very good thing to happen in India. As we all know, there are 4 paradigms of science, and since time is limited, I'll just mention that we are in the 4th paradigm, which is data-driven science, where data is the oil. Anything we do, it is driven by data. The science that we do is also driven by data. That is why we have this term called data science, where we have to understand, if we look at a large amount of data which is showing up a certain pattern, there has to be a scientific principle which has given rise to that pattern, and that will drive how scientific discoveries are going to be made. That is what is happening these days. And that requires greater, very strong collaborations between academia, industry, as well as the government. So as we all know, it's an explosion of data. Let us not get into those. I mean, that has been discussed time in and time out, I mean, many, many times. And artificial intelligence and machine learning will be the driving forces. Great opportunities of doing problem-driven basic research. We cannot ignore the basic research while we focus on applied research quite a bit. We cannot ignore basic research, and but the point is, it should not be just research. There will be some research which is purely for the sake of, for the enjoyment of problem solving. But there should be something also which is driven by national missions, very large missions, and that will give rise to a large amount of basic research, along with innovative applications. And something that we have not focused on much is converting knowledge to wealth. And that is where we are, I think now many institutions are focusing, IITs quite a lot, are focusing on conversion of knowledge to wealth. Institutes like ours, which are primarily theoretical, are still a little behind. That is where we also have to catch up. And as has been mentioned, the Niti Aayog discussion paper on national strategy for artificial intelligence and national strategy for AI. These are the focus areas, as you can see here: healthcare, agriculture, education, smart cities and infrastructure, smart mobility and transportation, congestion management, etc. So we have all these areas. I would today be focusing a little more on the healthcare side, because that is where my research generally lies. But the opportunities are immense. With CPU, GPU, and TPU computing facilities available now and cloud services available, it's like all the infrastructure is right now at our doorsteps. So it is not fair to say these days that something cannot be achieved because of lack of infrastructure. And we know that market is projected to grow at a very high rate by 21.4%. It has already grown in 2018, and it's going to grow up quite a bit. Reduction in storage costs, it's a huge amount of storage is now possible, and also over the cloud services. So infrastructure, we are not limited by infrastructure these days. What is actually limiting now is the AI solutions, the machine learning solutions, the algorithms. We have huge amount of data. How do we make sense of that data? How do we do the analytics part? That is where the block has come in now. Spurring the requirement of large number of data scientists who are well trained in statistics, mathematics, and computing. So these are the basic areas where we need very highly skilled personnel, and then they can go into different areas of applications. No problem with that. But the basic statistical tools, basic statistical knowledge, basic, very deep grounding in mathematics and in computer sciences, that is the basic building block these days. So as I said, infrastructure is not a problem anymore. Storage is not a problem. Data is there. What is limited is the ability to get information, to analyze that data and get meaningful information. The challenges, of course, I have written there, the government academia industry disconnect. There is while we want this connect to happen, till now there is a high level of disconnect because of the differences in nature, because of the difference in the language we speak. Academia typically is, people in academia are intellectually very curious, they are active, but they lack discipline. And but also with lack of discipline comes a lot of innovation. You see, too much discipline, too much regulated life lacks innovation. So academia there's a lot of innovation happening in academia, and there's a lot of possibility of innovation. Because of that curiosity, a sort of by nature an indiscipline. We don't keep proper records of what we do. We don't keep proper reports of what we do. And therefore, we often get bored. I have written here, quick boredom of the research faculty from whatever they're doing. After they've done a significant amount of work there, then they move on. And when they move on, they've almost forgotten what was done. So we just publish papers in the academia, reports and thesis, and then there's a quick boredom which sets in, and then we move on to another area. Therefore, attrition from an area is high. Attrition not from the job, but from the research area. Going into a new area, and once we move on to a new area, we forget about what was done in the older one. And rarely, this is not too much in India, we rarely file patents. We just focus on open science and publications. And even more rarely make it a marketable product. We don't care in the academia for scalability, for salability, for the look of the product, for the properly designed GUIs, etc. Get an algorithm working, and that's it. Industry, of course, cannot be as indisciplined as that. It has to be disciplined. It has to be driven by intellectual property and more towards closed science, and focuses on the commercial aspect more than the scientific aspect, with an eye on profitability. That is how it is structured, the very nature of it, and has this capacity and the tenacity to take a product to its entire life cycle. So this is quite in contrast with how the academia typically works. And it is because of this difference in nature, difference in work cultures, difference in languages, that this disconnect is there. So academia, we take more time to do things, think that they have the entire lifetime to do some research, work at a slower pace with more appetite for risk. Once you become a professor, you can afford to take risks and can afford to fail as well. Industry, of course, works with strict timelines, has to be fast and nimble, with less appetite for risk, and can seldom afford to fail. So these are the differences which causes the disconnect. And it is, I believe, I don't know, I thought I had it here, but what I wanted was, if there is a closer interaction, a seamless movement between academia, industry, and the government, maybe this difference, the barrier of the language we speak, can be broken down to a large extent. In the Indian scenario, as we can see, we spend only about 0.6 to 0.7% of our GDP on research and development, while US, China, Israel, Korea, these are some examples you can see, they spend much higher. Our human resources that we engage in research is very low, just about 218 researchers per million population. While, as you can see, South Korea, it's so high, USA is 4,000 plus, even China, it's about 1,200 now. However, our scientific and engineering publications, we are quite high up in the rank 3, and we publish about 5.31% of the world's publications, while China, as you can see, is number 1, 20.67%, US is 16.54%, behind us come Germany, Japan, UK, etc., etc. However, our growth rate is very high. It's about 11%. From 49,000 papers in 2008, it's now about 135,000 papers in 2018, which is, I believe, quite a jump. China has a growth rate about 7.8. US has been very high, but with a very nominal growth rate of 0.71%. Anyway, they have been at a high publication coming out of US anyway. Only about 15.8%. I'm not very sure about this particular statistic here, but I've just put it there. But 15.8% of India's research go into the top venues of the world. At the same time, while we spend a very little amount of money, we publish quite heavily, and therefore we are almost in top rank in the number of papers published per dollars spent. But whatever it is, whatever funding has happened in the research, whatever research has taken place, we are going up in our publication statistics. Everything is fine, but the question is, if we will be hard pressed to come up with some breakthroughs which have come out of India. So there's a typo here. So where are the breakthroughs? What has been the impact of Indian research on the Indian industry? Of course, now the startup culture is booming, but maybe very few of them have been derived from pure government funding. And also, it's time to think whether research output in India is indeed affecting the economic growth, or is it just because we train good people that whatever they do is good for the economic growth? That is what is happening. Is our lower focus on the quality of primary and school education affecting higher level research? I believe it is. I believe we need to focus quite a bit on the primary and the school level education, because that is where the minds are created. And then if good minds come, innovative, curious minds come up to research, then of course the research outputs will start affecting the economy. So we have not built that great companies out of research, solely out of research. So need of the day for me, it looks like mission mode futuristic national level projects, which will force a lot of basic research as well, and has to be driven by primarily the government. Business interest, the problems of business interest, that research primarily has to be industry driven. Creating knowledge for the future has to be primarily academia driven, and continued focus on purely theoretical research, which anyway need very little funding, has to continue. So without going into the details of this, because kindly tell me at least 5 minutes before I need to wrap up. So give me a warning. But stronger interaction, as I was saying, stronger interaction and seamless movement between industry and academia could be like mandatory timeouts for industry practitioners to come and spend time in the academia to teach, to supervise research, and mandatory industry internships for academic and scientific staff, faculty. Mandatorily, you have to spend, let's say, 6 months over a period of, let's say, 5 years, whatever it is. But you have to go and spend time in industry, something like that, which will allow a seamless movement between academia and industry, may spur greater collaborations, and may break the language barrier. A larger funding, industry funding to academia, of course, there'll be some project-specific funding, but open funding as well. what we've seen is industry funding of academic research as it goes up, the basic science funding somehow tends to go down. In the smart healthcare area, so there, of course, the possibilities are immense. There's huge amount of data and complex data. Not all data is big, and you don't even need big data all the time. You have complex data, you have different levels of data, like sequences, genomic sequences, transcriptomics, proteomic sequences. You have graph data, you have structural data, images, clinical information. Taking a multi-source, multi-level view of all this data and doing the analytics, huge amount of possibilities exist. Data science and data analytics in healthcare, can be descriptive. For example, what happened in the past? You look at the data and try to figure out what happened. Predictive, like what may happen. And in medical domain in healthcare, what can happen is very important to know now. And prescriptive, looking at the past and the present data to understand what should be done if something happens. Personalization, hugely important in healthcare these days. What is the specific thing that should be done and that I can do for myself, or can be done for me in particular, not a generic thing. So personalization medicine, personalization therapy, these are all of high research as well as high industry value these days. Revolutions in healthcare have been over the period of time, like molecular and cellular biology, discovering the structure of the DNA. At the genomics level, looking at the entire genomes and understanding the genetic basis of diseases has been the revolution in genomics. And now it is the era of convergence. The life sciences, engineering sciences, physical sciences, mathematics, all need to come together. The industry which will be the healthcare industry of today has to focus on getting expertise from all these different disciplines. A single discipline industry is not going to work, at least in healthcare, anymore. Computer science, a huge amount of importance of computational methods, statistical tools, statistical analysis, mathematical models, all have to come together to build not only research, but also to build industry in healthcare, in the area of healthcare. So computational biology is something which I do, and I thought I'll just give a very quick peek into what I have been doing. And essentially, as you can see here, I've been working in the area, primarily in the area of machine learning in biology. And machine learning, actually, we tend to confuse, many of us who are not really experts in this area, we tend to confuse between what is artificial intelligence, what is machine learning. And these days we are hearing a lot about deep learning and digital handling of information and data. So not everything that is computerized is artificial intelligence. Not everything that is artificial intelligence is machine learning. Not everything that is machine learning is deep learning. These are all AI, ML, and deep learning. These have a subset relationships. And as you can see here, just capturing the data in databases and responding to queries has nothing to do with artificial intelligence. It is pure just database retrievals. What is machine learning? What is artificial machine learning in particular is essentially the machine will react intelligently to new situations it has not seen before. It has seen certain, for example, certain images of dogs and cats, but a new image, it's a new cat. It has this particular picture the machine has not seen before. Can it conclude that this is a cat? That is what machine learning is. It has to learn from available data in order to be able to tell something about unknown data. So there has to be a learning over there, learning to new situations without explicitly programming it. That is what machine learning essentially is. And I've been working a lot in cancer with regard to a particular small molecule called microRNA, which essentially what microRNA does is it interferes production of proteins, important proteins inside the cell. So what was important is, given a new microRNA, can I say what protein, forget about all these details here, what protein it may inhibit, the production of what protein it may inhibit. So I have some known information. I know that some microRNAs, they target certain other molecules. And this is my training data, target and non-target. And for a new pair, I need to figure out whether it is going to target or not. It will not target. This is something that we worked on. We came up with our method, which we published. And you can see this is the result of our method, which compared to all other state-of-the-art methods at that time, had a very good performance in terms of very low false positive rate. As you can see here, on this side, it has low false positive rate and high true positive rate. So that was a good thing to happen. But then we published, and that is where we stopped. We did not patent it. In fact, we went ahead and used this work to make predictions for certain cancer. For example, to make predictions for breast cancer. And we predicted the 3 microRNAs which could be important, of which, we predicted 5 microRNAs which could be important, of which 3 we already saw from the literature that that information was known that these 3 microRNAs are important in breast cancer. But for 2 of them, information was lacking. So this was an important prediction. We published and we stopped. That is where that is importance of these methods for the industry, for wealth generation, for healthcare. So these are the things where industry connect has to be set up. And I must admit that is where we lacked. That is where we have to build the bridge. Similarly, results for colorectal cancer, where we made important predictions, but we just made it open, and that is that. So it is no harm in making such important predictions out for the public, for the community, academic community to take in. But using these same methods, same algorithms, with some possible modifications, it can go into very intellectual property owned. I mean, IP can be created, and we can do it. Similarly, we worked with very effective clustering algorithms.
Can I come in now?
Yes. So
you'll have 5 more minutes.
Yeah, certainly. Thank you. I will finish. So we work with clustering algorithms. People work a lot with clustering methods, but this was an interesting clustering method in the sense that these were taking single cell data from organisms. Typically, when computational biologists work, they have been working with bulk data, where you have a number of cells, you extract information, you extract materials like RNA material from a number of cells, and then you do your analytics. But then what happens is individual cellular level differences, they get masked out by such bulk information processing. But we know that in cancer in particular, even the cancerous tumor has a lot of heterogeneity, and that has to be captured, which cannot be captured if you do the processing at the bulk level. Now, technology has come in where you can look at single cells. But then what happens is, you will have a data where there are very large clusters, points which belong, a lot of points which belong to a single cluster, but there will be, rare cell types. Only maybe out of 1,000 data points, 1,000 cells, maybe just about 10 cells, they are rare cells, they belong to a separate cluster. But the clustering algorithms which exist, they cannot detect such large clusters at the same time such small clusters. We worked in this domain. We solved that problem in one way. Of course, people work in different ways and they come up with newer algorithms. But we did, we came up with algorithms where I have marked here, a cluster as small as this has been detected separately from larger clusters. This is an important algorithm. This again, we published, as you can see here, in 2018. The first version came in 2020. The next version was published. And that is where we have stopped. We have not converted into intellectual property yet, or try to see how we can generate wealth out of it for the country, for ourselves, whatever. So also we worked in drug design, where we came up with new methods which could help in designing small molecules from scratch on the computer. And there have been past successes. As you can see here, Peter Coleman, Australian scientist, designed a flu drug called Relenza through computational methods, through principles of rational drug design. And these are important innovations. We also came up with such innovations, and without going into the details of that, let me just mention that we took some results on the tuberculosis, the Mycobacterium tuberculosis, on a particular protein of this bacteria. The protein was called RECA. And what RECA does essentially is when this bacteria infects, then we take antibiotics, and this antibiotics goes and destroys the bacterial DNA. RECA helps to repair the bacterial DNA. So if we can stop RECA from doing its function by designing a small molecule which will go and bind with this bacterial protein, then that is a possible lead molecule. And we had our own methods, and you can see here we came up with our own methods for this particular work, and we came up with new possible lead molecules, which again we published, and that is where we stopped. So without going into the details, I think we are I would like to conclude with the roles and responsibilities. I think from the government side, a lot of focus on quality school education, high school education, that can spur future innovations, innovative mindsets, and value-based education. That is very important, because that integrity, that value system has weakened. And with a weak value system, what is happening these days is too much control, too much monitoring, too much, what should I say, mistrust is arising, and one cannot really operate. No research can operate with such a mistrusting environment. That cannot happen. We have to increase research funding and reduce bureaucratic hurdles, increase trust in the scientists. Academia also has to build a conducive and enabling ecosystem, having facilitating rules and regulations and incentives and appreciation for good work, tolerance for failures, and acceptance that not 100% of the resources will be fruitfully used. There will be some wastage, but intolerant of unethical practices. And industry, to increase the quantum of research funding significantly, set up the state-of-the-art facilities in the academia without project-specific deliverables, and think on a long term. My acknowledgements to all those who have helped me in whatever I've achieved till date. Thank you very much. And I must say, at this point, we are trying to rectify, I personally am trying to rectify this industry disconnect by trying to build in mechanisms so that we have now a cell for collaboration with between academia and industry. And our industry collaborations, Industry Connect, is going up. I myself have engaged myself to mentor a startup in the area of precision medicine. So with that, I would like to conclude. Thank you once again for the opportunity of sharing my thoughts. I'll just stop sharing.
Thank you, ma'am. Thank you very much for your time and for vividly breaking down the pressing points we need to focus on to build and then endure better industry and academia partnerships, and touching upon the possible solutions. From industry, we have a team from Intel Corporation. Anant Narayanan Shanmugam is currently Director Government Affairs and Public Policy India for Intel Corporation. Prior to this, he was associated with Wipro Limited as Corporate Affairs Technology Advisor. Today, Ananta will provide a bird's eye view of Intel's work on AI. He will be joined by Verma S. Kunala. Verma was recently deputed from Intel as the CEO of INAI, the Applied AI Research Center at IIIT Hyderabad, a public-private collaborative effort between Intel, IIIT Hyderabad, and Government of Telangana. He will be talking about the nitty-gritties of how they built this partnership and their goals to apply AI to improve healthcare in India. So over to you, Ananta and Verma.
Thanks a lot, Dr. Seelig. Am I audible?
Yes.
Yeah,
So thanks a lot for inviting us. Thanks to the PSA office and the FICCI team for having us here. It's a pleasure to be here. What we want to do today is, actually talk about what has Intel done in this space, and I must really thank Dr. Sangamitra, right? But she actually laid down the problem in a very, very succinct way. Actually, the core issue of, what is the challenge that we have in India, in terms of industry, academia, and government partnership, right? And you would see, as Verma would explain, those are some of the aspects that we've been trying to really work on and fix some of those part, right? So the Intel work in India, especially in AI, started about 3 years back. Intel India today is the largest R&D center out in the US for Intel, and we've been working on AI for more than 7 years now. even before many of the things became a big thing. The reason why we started in India is really the impact that AI can actually have on the global economy and not specifically on India, right? And one of the key consideration is, if you look at it, right, the economic impact alone today that AI will have in this decade is about 15-16 trillion dollars of economic activity would happen based on AI and AI solutions, right? Now, out of it today, we are projected to have about 1/16 of it, about $1 trillion, and even if we have to achieve that potential, right, what we need is a way, and this is not going to happen all by itself, right? We need to have a way in which we can actually structure us around ourselves, where we get the best out of industry, get the best out of academia and government, to come together to sort of achieve this potential, maybe maximize this for not just us, also for the globe. Next slide. If you look at it, when we started this work, around 2018, that's when the national AI strategy was being discussed, right? I think, we did our own study on this thing, and we said that if we have to, country as a whole, if we have to typically look at gain the advantage of what's happening, then we need to work on 4 key areas, right? One is data. India is the largest mobile data consuming nation in the world, but that data needs to be in a form that could be used by our researchers and also startups, right? So we need a framework where we could get this data, curate it, and bring it in a way, shape, and form that our startups and researchers can readily use it. So that's a big thing that we need to do. While people keep talking about data availability, the data curated data availability is very low. I think we need to do a lot of work on it. Second thing, talent. Talent is a critical aspect of it, and that is something that we need to focus on. We need to really work on talent generation, creation across all the levels, right? And we identify this one of the clear areas. While more from a startup, we are one of the largest software ecosystem and startup ecosystem. Where we really lack is the core, research-based talent that can actually create fundamental AI IPs, for the country. So that is an area that we need to work on, right? That was identified as a core area that needs to be done. The third thing was, with all this stuff, what we need is, this is really what Dr. Sangamitra spoke about, right? A focus on, trying to a national mission kind of a problem solving mode, where we need to apply these things to national scale problem for us to benefit out of it, right? That's one. So we said there are 3 key pillars to that. One is we need to start looking at applied R&D with a focus on a specific set of problems, especially national set of problems, right? That's one. Second thing, how do we enable entrepreneurship, right? How do we make it easier for startups to come build solutions, and things like that. And third thing is, we just not only build it, right? We should also use it, for us to create the impact and benefit out of it. That's where the adoption piece comes in. And finally, we need government focus on trying to enable all these activity. If you look at AI is actually something very new. And we need a lot of policy enablement to happen for us to be able to use AI in a different way than what has been previously. For example, healthcare. Healthcare is a lot of regulated data, and we need to figure out ways to fix that. So policy enablement is actually a very critical aspect of it, right? So what I would talk about next is, while we identify these as the problem, right? And we've been working in the past 3 years. Varma, can you go to the next one? Right. Our strategy focuses on 4 areas, skilling, right? Applied R&D, startup, and adoption. What we have done in the country today is that, from skilling perspective, we are skilling across the spectrum of people. We have programs today where we are skilling youth. We have already done 200,000 kids, 2 lakh kids in the last year. We'll continue to do the same thing. We have programs, where we are training, reskilling, or developers and others. We have programs where we are actually, imparting, AI-based skilling to government leaders, and we have a target of doing about 5,000 government leaders today. We have curriculum, we have experts who deliver those programs, right? And not just that, we want to make AI a national kind of a stuff. So we are coming up with, skilling for citizens, where, we are launching programs where we would sort of offer citizen skilling in 10 different languages, where people could understand what it is and maybe better use it. And that's been one of the pillars that we worked on. The second is the most important pillar where I told you is that, applied R&D. This is actually a culmination of INAI, which in Tamil means, to bring together. It's actually our applied R&D center, which brings together government, industry, and academia to actually solve national level problems, right? And we've been working. It was launched last year in October, and that is where we are focusing on in our applied R&D. And Burma is actually being deputed from Intel into that center to lead it, right? And create that necessary momentum that we need. Next thing is startup. As I told you before, we are doing a lot of facilitation in terms of getting mentorships for startups, helping them with data, tools, compute resources that could help them to sort of, scale the barriers that they find today, so that it is easier for startup to start working on solving many of these problems. And finally, we are starting a center with the Indian School of Business focused on helping government adopt AI technologies. Today, there are many such solutions available, AI, which can be readily adopted by government. And the challenge is, there is lack of capacity, capability, and sort of ability to use some of these stuff. So we are focusing in partnership with Indian School of Business to sort of address the problem. We have a center that has been started, and like that, we are doing many. So we are doing a road pilot. We are doing something called AI for road safety. We are trying to work with various partners to fix the problem of how do you use AI and natural vision processing to sort of avoid collision and other stuff. And that's an area that we are working on. In all, if you look at it, the way we have worked and way we think it needs to be carried forward is it need to be a collaborative effort between industry, academia, and government. Each of us have their own set of strong points, right? And we need to come together to sort of develop and further this. And the last thing I would tell you is that while Madam in her presentation spoke about government-led initiative, we have taken a different approach where we said that applied R&D should be led by an industry, supported by academia and government. And the reason why we feel is that the place where we fall short of, which Madam spoke about, is that taking that research to a final product and creating that impact, right? That's an area where industry does really well. We take fundamental research, productize it, take it to the market, right? And that's the problem that we need to solve, and that's what Burma is going to talk about. Burma, all over.
Thank you, Ananta. I think Mr. Dilip, right, and Professor Sangamitra talked about the issues, right? And hopefully I can relay my experience over the past, let's say, 6 months, right, of doing this thing, right? As Ananta explained, right, so this NI came about because we really wanted to go about this in a collaborative way, right? So we launched this in October, right? And the collaborators in all these things, right, they came out because each one brings a particular strength, right? From Intel, we bring the industrial expertise and the architecture for AI, right? And IIT Hyderabad has one of the biggest faculty and PhD students in AI, so they bring that strength. And the Telangana state government brings the resources, whether it's the healthcare, right, all the healthcare facilities and other things. Then we also have a domain partner in healthcare, Public Health Foundation of India, who have a very strong presence and expertise in the public health space, right? So all of us got together, right, and it did this institute, right? And we have two focus areas, smart healthcare and smart mobility. I'll talk more about smart mobility, healthcare in this session, right? Smart mobility, I'll touch upon it a little bit. Right? So in terms of objectives, right, the first thing, obviously do high impact research, right? We want to go after real problems that are impacting the society, right? So, but to do that, right, the first thing we need to put together is data sets, right? So prior to taking this role, I was leading Intel India's efforts in to build AI solutions in healthcare. I interacted with quite a few startups, right, both in India as well as across the world, right? And the single biggest problem for all of them is well-curated data sets, right? They end up spending significant amount of money and time on that they don't have to, right? So if we can help with that, right, that solves a lot of problems for a lot of startups in actually taking their product, right, from conception into a real product out into the market. So once you have the data, you also need to have tools and frameworks to use this data and build your final solution. Even here, right, we can do something, especially in the emerging genomics area, where we can put together pipelines and tools that can be a common infrastructure for a lot of these startups and other organizations to use, right? And then innovation entrepreneurship, right? A lot of people come with ideas, right? And then we'll need to help them to translate that into actual products, right? And the last thing Ananta already talked about, right? Actually building, right, human capital in this area, right? So these are the overall objectives, right? And then I'll want to talk about specific considerations we had while we were conceptualizing this thing. And also, I've been on this thing full time for the past 3 months, right? So I can also talk about the real world experiences, not just the conceptualization when we wanted to do this thing. The first one I call immersion, right? What I mean by that is, so we launched this thing October, right? Over the second half of last year, we were engaging with, all the faculty at IIIT, with the government and all these folks. We have lots of meetings, we talk about it, and then after that, we again have meetings, right? So that's what I call outside, right? But over the past 3 months, every time I took up this role, I actually go to IIIT, right? Now we have a center, I sit with them, right? I work with them on a daily basis. That makes a tremendous difference because you sit in their environment, right? If you're in the industry, you're sitting in your environment, and the academia, even though you're talking. Oops. Can I continue? Okay, yeah. Even though we talk to each other, right? Once you actually go sit in their environment, that gives you a much better appreciation, right? For the kind of problems you need to go solve sitting there, right? That's number one, right? That's helped me a lot actually sitting with them, right? Second one, ambition, right? Again, this, I speak because working in Intel, we interact with customers and research institutes worldwide, and we see in the scale of problems those guys want to solve. And also we see the scale of problems that we're trying to solve here. Again, there's historical reasons because we think of solving problems within the scope of the resources and the money that we have, right? And obviously other institutes worldwide have much bigger budgets, but now we're also putting money. So we should also, increase the scope of what we want to solve, be more ambitious, right? That's number one. The third thing is I'll call pace and planning, right? Again, I think Professor Sangamitra also addressed this thing where, right, when I go, like my first experience, okay, let's make a plan for this project. When I say 4 or 5, the professors are saying 4 or 5 years, and I'm saying 4 or 5 quarters, right? I'm thinking quarters, they're thinking years, right? So there's a difference in the timeline that we're thinking about because in the corporate world, we're used to, right, much shorter timelines, right? That's third one. Fourth, an end consumer orientation, right? Again, right? When you start a project, typically an academic project starts with the research, right? And towards the end of it, you think about, okay, now what do I do with it, right? If I turn it into a product, what will be the end customer experience, right? So this again, right, coming from the industry, we can bring this thing right at the beginning of the project itself, saying that, hey, you need to think about all these things, assume the best case scenario, right? Okay, you're taking some risk with this research. If it doesn't work, it doesn't work. If it works and you want to make this into a product, how does it, become a real world product? Think about it, right? The last point also similar, right? It's not about just developing technology, but having a product mindset, right? How will the end customer use it, right? So these are the considerations we have when we put together this thing, right? And all these, I can say, right, we've been sitting with them and we've been addressing all these things in the projects that we've been looking at over the past 6 months and actually on the projects that we kicked off. So a little bit on smart mobility, right? This actually, we have been working for the past 3 years, right? Although the institute started only or the last year, we had a long-standing relationship with IIIT where we've been working in this thing. This is along 3 vectors. The first thing is actually the government of India has this vision 0, where you want to almost, get to 0 accidents or deaths by 2030, right? India has one of the highest accident rate and death rate in the world, right? Here we have, AI technology, AI for road safety, right? We have these devices from a company we bought called Mobileye, which is just a camera based device that you can put on your dashboard in your vehicle and it will give you collision avoidance, right? If you can get that collision avoidance alert just 1 or 2 seconds before the accident is going to happen, that will reduce a lot of accidents, right? So that is one area we're spending significant amount of time. Again, this is an example of applied AI research, right? Solving real world problems that will impact the society. Right? The next thing is tools and platforms. While we're working on these driver assistance technologies, right, looking into the future, we also are putting together a platform with all kinds of sensors that can be used by researchers working in driver assistance and autonomous navigation, so that they can come and develop their algorithms, test their algorithms, right? So giving them a platform. The third one is a driving data set. This is something that we've been doing for the past 3 years. So it's called IDD, Indian Driving Data Set. So this is the only driving data set that is out there, which we call unstructured driving conditions. So we equipped cars with bunch of sensors, and they went around in bunch of cities here in India. And this is the only open data set, right? If for a researcher to come and check, to come and test their algorithms, right? So these are the three vectors for the smart mobility, right? Now coming to healthcare, right? Let me spend a little bit of time, right? Again, I know some of these are still work in progress, right? So I can't talk too much detail, but I'll give the details that I can give out, because some of them we kicked off, some of them we're working through, right? So the different dimensions of the work we're doing, right? The first thing we already talked about, right? Data sets, right? Given the size of our country, right, we should have really good data sets, right? I mean, in America, the private corporations have a lot of the data sets. In China, everything is owned by the government, right? Here, we really have an opportunity to put together really population scale data sets that can be used by anybody, right? So why is it not there? Because there is no concerted effort, right? So that's one thing we want to address, where we want to take, there is a lot of raw data in a lot of places. If you go to hospital, okay, they have a raw data. But what companies need is curated, annotated, cleaned up data. That doesn't exist. So we want to put some effort in this area where we, collect all this data, put in some effort to clean it and annotate it, right? That's one aspect. And the second thing is, again, we need to put together some tools and frameworks, right, to go along with this thing. For example, in healthcare, right, there's a lot of privacy concerns, right, where some of the hospitals are willing to share the data, but they want the data only to be in their hospital. So we need sort of a secure federated framework where the algorithms can go work on that machine in that hospital without the data coming out of that hospital. So we need to put together that kind of architecture where the privacy is also taken care of and the data doesn't leave the premises. Right? So there's a lot of work to be done in that area, tools and frameworks. And then collaborations, obviously, right? There's a lot of expertise in the country, and this is one of the key areas. Wherever there is expertise, we want to go there, right? And I just heard Professor Sangamitra, right? So probably I'll talk to her right after this thing, right? Because the areas that we are looking at, there are four broad areas we're looking at, right, in healthcare. The first thing is public health, right? There are two vectors in here. First thing is in terms of primary healthcare, right? There is a lot of scope to actually use technology to really increase the coverage in primary healthcare, right? A lot of problems we have in our country is because the tertiary healthcare is really overloaded. You take AIMS in Delhi, for example, right? 10,000 patients per day, right? There is no reason why that should be like that if you can actually take care of or provide good healthcare in the primary healthcare space, right? So we are working right in developing solutions in that area. And the one is genomic surveillance, right? Actually, we have worked last 1 year with IGIB in Delhi and IIIT, a COVID risk stratification project, right? So we all wish the pandemic goes away, but I think it's very one thing we learned is that the mutations are going to happen a lot, and we need to have real-time information of what's going on, right? So we have a proposal to put a genomic surveillance network, right? That's on the public health area. Second thing is cancer, something that Professor Sangamitra talked about, right? Now, non-communicable diseases are becoming a bigger and bigger burden for our country, and cancer is top of them, right? So we are actually looking at the top 6 cancers, right? Oral cancer, brain cancer, and gastric cancers, right? On screening, early prediction and therapeutics on all 3 areas. So we actually have 3 different partners who are working with on these things, and given what I just heard from Professor Sangamitra, we'll follow up with that as well, right? The third one, mental health. Again, this is a big area. People don't talk about it much, but this is a bigger area even before. But over the past 1 year, right, this has become even a bigger concern, right? And so we have active collaboration with NIMHANS, and we're looking at a couple of projects in that area. The last one is drug discovery. So this again, earlier when people used to talk about drug discovery, it used to be okay from start to finish 10 years, right, or even more. But now over the past 4-5 years, if you look at the number of startups in this area, right, it exploded, and the timeline is getting smaller and smaller, right, in terms of from the start to when you can bring a drug to the market, right? So here we're actually putting together a protein ligand data set that addresses a lot of the shortcomings of the public data sets that are out there, right? I don't want to talk too much into it. So in all these 4, right, we have active projects going on, right, taking into consideration all the things that I said, right? All these things, we have end customers, right, in mind. We have end applications in mind. So these are all something that will go into the market and used by somebody, right? For example, on this drug discovery, right? We're talking to a couple of drug companies right at the very inception of this project, not 1 or 2 years down the line, right? So these are the kinds of things we're doing right now so that all these things go into the market. Okay, I think that's all I have, right? So just to summarize, right? So the high level thing is that we really want to solve population scale challenges, right? And real problems out there, both in healthcare and smart mobility, right? And this model we have put together, right, is to bring all these parties together in one place and do it together, right? Well, sitting together actually, right? So we just started our journey, right? Hopefully this will turn out to be a successful model to replicate across the country. Thanks, Uli.
Thank you, Varma. Thank you so much. Thank you, Ananta. That was really covering everything that we talked about that we would expect for somebody who's working in healthcare to talk about. So thank you for being really detailed during that presentation. I think Mr. Chinoy has left, right? Yes, I think Mr. Chinoy has left. Okay, so we have had a pretty long presentation, so I would have one quick question for all of our speakers, and a very basic question. So all of us do agree that there does exist a disconnect between academia and industry. So can I have a quick word from all 3 of you on how to build an ecosystem that teaches young researchers the language that industry speaks? And how early should we start? I know Professor Bandyopadhyay did touch upon a bit about starting quite early as in school, but would want to know from all 3 of you as to what you think. A quick word. Ma'am, do you want to go first?
Okay. No, about the industry connect, I did not mean that it should start in school. I don't think I have ever thought about that. It should start later on. What I wanted to start in school is the quality education that is imparted, and that has to go up, and also value-based education.
Right.
Value in the sense, strong. The individuals that we turn out should have strong values. Otherwise, later on, the trust will not come. That is the point. Now, about this industry connect and how it can be initiated in the young researchers, I think the solution has to be a seamless movement between industry and academia. So that, for example, a PhD student who is working in a particular area which is of some interest to the industry, in a corresponding industry, if that person gets his or her fellowship, yet can officially through a proper process spend 6 months to a year working in the industry environment, as I think it's Dr. Verma, right? The name Verma. Yeah. So as you mentioned, it was so important to come and sit in the IIIT Hyderabad. That's what I think, if I got him right, that's what he said. So this actually being immersed in the others ecosystem is very important. If academic institutions, like big institutions who have at least some space to spare, can allow industry to set up laboratories there, I mean, that is an office of that particular company itself. For example, Intel or something, XYZ, whichever, comes up and sets up shop within the premises of the academic organization. This is much easier said than done. There are many, many hurdles, many issues which have to be ironed out before this can actually happen. But that is one way in which this disconnect might be reduced to a large extent.
And on how early this can start?
I think in the research. I mean, before that, there are students who do internships in the industry, like at the master's level. But since we're talking of more in the research aspect, I mean, from the PhD, once the person starts doing a PhD, he or she spends some time in the industry. The industry also sponsors their their employees to come and work on certain problems with corresponding faculty members, and I think this disconnect can be broken to some extent.
Thank you, ma'am. Verma, do you want to go next? Verma,
maybe 3 points I'll say. Right, the first point I'll add to what Professor Sanghumitra said. Right, in fact, IIIT does that now here. Now that I've been here, I see it where when they're working with some company, right, say a project, they say get your people here, right? We have dedicated space. Just you don't need to I taken care of all aspects of this space, right? You don't need to pay anything, right? Just be here, right? That just being here and working together itself adds a lot, right? That's number one, right? Number two, I think in terms of the mindsets, right? The mindsets also have to change, right? I mean, I do it every day whenever I talk to all the researchers here and the faculty, right? Whenever we take a project, I always talk about end customer, right? They're not used to that kind of thing. There are some projects which are open-ended and fundamental technology, they have to. But when you're talking about, developing an algorithm that can be deployed in a hospital, let's go sit down with the hospital, right? And having an end customer also puts some sort of date on it, right? So that it's all contained and you get it out, right? So these things, you have to make it as a culture, right? And it will happen slowly, right? So
I'll just quickly add. I'll just quickly add to that. At least what we have done in the country. I think there are 3-4 things that we could do, and we are already doing it. One is, we have this program every year where we hire about 100 interns, right? That's an open call given. That's a joint program done with the Ministry of IT. Where we go across the college in the country, get 100 interns, get them in, right? And they work with Intel for about 6 to 1 year, right? Within the framework, typically the PhDs, MTechs, and to a less extent BTechs, right? So we have that program, and what we have realized is that program really is a very, very powerful way of doing things, right? One, we are actually able to give quality time to the people who come into the industry, right? Get them work, they understand the industry, this thing, and when they go out, right, they're already ready, right? They've worked in a world-class institute, right, and they are ready for the world, right? So that's one. And it also works very well for Intel because we have already trained them, and about 60 to 70% of them do get absorbed by Intel themselves, right? That's one. Second thing is we got to do more outreach to the researchers, right? We do an annual symposium where we call in that is topic based, and based on the topic we call all the researchers, right? Maybe you got to do more because of that, where we get industry and others to come and do that, right? We have found a lot of benefit by doing that, simply because it actually opens our horizon of what is happening in the academic institutions, right? What are some of the people working on, and we benefit from a lot of those stuff, right? And more from a research and thing, right? They got to be reaching out more to the industry as well. I think from an industry perspective, industry is always that are open and to work with researchers. Maybe we need to create formal institutions and formal mechanism to do this. Maybe centers like when we said that that is one of the things that we want to go ahead and do it, right? And not just that, we also want to do that for the faculty. We want to create a program where faculty comes and work with Intel, or as part of our team, and then understand what's happening, right? So many of the things, we hope to do through INI, right? And many of the things we're already doing, right? And the thing is, we need to expand all those good work that's already been done, right? Maybe we should make it an industry-wide initiative.
That's really helpful. Thank you. Thank you everyone for agreeing to be a part of this session and giving us your time. Over the last year, the Office of PSA brought together many industry partners from academia and startups to develop innovative solutions to support different R&D problems through the Innovation and Science at Bharat initiative. This series, we hope to build and nurture more such partnerships. And as Mr. Chinoy pointed out, I hope this session results in at least one such. You can find the list of team members. I'll share it in a while. And should you have any queries about how to build partnerships through this initiative, these are the people who you can write to. So thank you to those who joined today's session. I'm extremely grateful to the teams from FICCI and Pune Knowledge Cluster for helping us put together this series. If you missed this session, the recording will be available on our social media accounts, and the video will be there on our websites. Do join us for our next session on AI in agriculture. Stay safe, everyone. Thank you.
Thank you.
Thank you.
Thank you very much.
Can I stop live streaming?
Yes, please.
Thank you.